Hey guys, this is Mr. Bennett, and I'm reviewing how to set up and solve a three-step stoichiometry problem. So with any stoichiometry problem, you always need to start with a balanced equation, chemical equation for the reaction. So I have one here over on the right that I've written down. We have nitrogen gas, which is a diatomic N2, combining with 3 moles of hydrogen gas, H2, and that's going to produce 2 moles of ammonia. So when I read my problem, the way that I identify that it's a three-step stoich problem is that as I read through it, it says how many grams of hydrogen, so that is my target, that's what they want. And I notice that the target units are grams, and then as I continue to read through it, it says how many grams of hydrogen do you need to produce 12 grams of ammonia. So that is my given. That's what they're going to give me to start with. And my given units are also grams. So anytime you have gram to gram, or mass to mass, it is a three-step stoich problem. That's your heads up that it's going to be a three-stepper. Okay, so to set up the problem, I'm always going to start with my given value. So the given value that's on the right-hand side of our problem here, identified it as the given, 12 grams of ammonia. I'm going to go ahead and write that down. So 12 grams. Ammonia, if I look up at my equation, I know the first substance is nitrogen, the second substance is hydrogen, so ammonia must be the last one, the NH3. Okay, so that's what they gave me, 12 grams of ammonia. All stoichiometry problems are conversion problems, so I need to do my dot line for my first conversion. And your units are always going to start off the same, meaning you look at your given amount, whatever the given amount is, in this case 12 grams, and those units have to be on the bottom. Okay, because you need to get rid of your given units. So those units will always be on the bottom, and the ammonia will always be on the bottom, or whatever substance you were given is going to be on the bottom, because you have to get rid of it. You're converting, you're changing from one to another, so we're going to need to divide grams of ammonia by grams of ammonia to get rid of them, to cancel them. Okay, the next step is that the only thing we can do with grams is we can convert it into moles. So opposite grams will always be moles, and it has to be that substance because the periodic table gives us the mass of each substance for 1 mole. So anytime you write down a conversion factor and there's grams on one side, you know it's a stoich problem, the other side of the line will always be 1 mole of ammonia. Okay, at least for our purposes in stoich. Now, what this has done now is I have 12 grams of ammonia times, and then when I divide by grams of ammonia, that's actually going to cancel these out. So these grams are going to cancel out, and these ammonias will cancel out. So now my units are actually moles of ammonia. Okay. The next thing we need to do is we need a number for that spot. So since the bottom was grams, that means go to the periodic table and calculate the molar mass of ammonia. So I have to find the mass of nitrogen, which is 14.01, and then I have to find the mass of 3 hydrogens. So each hydrogen is 1.01. So if I add those all together, I get 17.04. Okay, and I put that 17.04 on the bottom. Okay. Next step. So now I've gone from grams of ammonia to moles of ammonia. Next step, I'm going to get rid of my moles of ammonia. So you look at whatever's on top in the previous step, and that has to go on the bottom. So in this case, it'll be moles of NH3 so that they'll cancel out. Now, the middle of a three-step problem is always moles over moles, because you can only convert to go from one substance to another. You can only convert from moles of one substance to moles of another substance if you have a balanced equation. Okay, so the question is, if it's moles on top, what substance should go on the top? Well, your target substance, which in this case is hydrogen. So I put my H2 over here. If you're not sure if it's H2 or just H, go back to the original problem. The hydrogen's formula is H2. Okay, so now my second step is ready to go. I have moles of hydrogen over moles of ammonia, but I need some numbers. So where do I find these numbers? Well, moles over moles, you go to the balanced equation. The coefficient in front of hydrogen is a 3, and the coefficient in front of ammonia is 2. So I'm pulling those directly out of the balanced equation, which is up top. So notice here there's a 3 in front of hydrogen, and there's a 2 in front of ammonia. Okay. Also notice that now my units are going to cancel out. So moles of ammonia are going to be divided by moles of ammonia, so they disappear. Okay. Ready for my last and final step, I do my dot line. Now, currently, I'm left with, the only units I have left that haven't canceled out are moles of hydrogen. Those units go on the bottom, just like before. You're always looking diagonally up and to the left to figure out what units you're going to plug in on the bottom. So, my moles of hydrogen will cancel out, and notice they want grams of hydrogen, so I'm going to put grams of hydrogen here. Something else you can notice is that this step here and this step here are simply reverses of each other. The inversed. So the first step is moles over grams, and the final step is grams over moles. Okay, so I have my units plugged in. We need to do the last set of numbers. Remember, if you have moles opposite grams, they're always 1, because we get these numbers from the periodic table. And the periodic table values are for 1 mole of that substance. And then I need the mass of H2. Be careful here, because you actually have to find the mass of 2 hydrogen atoms, not 1. So it's going to be 1.01 plus 1.01, or 2.02. Okay, now it's just math. So once you've set up your problem, all of our units have canceled out. Notice these moles of hydrogen canceled out with these. So I'm left with grams of hydrogen, which is what they wanted. So I just have to do math. So I'm going to do 12 times 1 divided by 17.04 times 3 divided by 2 times 2.02. And that's it. So you'll solve for your problem. You'll solve for your value, and it works. So the last point I want to make is that all 3-step Stoic problems have the same skeleton, meaning you always have your given grams of substance A. The first step will always be grams of A on the bottom, whatever that substance is, we're just going to call it A, and 1 mole of A on top. Then the second step of a 3-step is always to go from moles of A to moles of whatever the other substance is. We'll say it's B. The final step will convert the moles of B, so we got to get rid of them, put them on the bottom, to grams of B. If you have a grams, remember grams, you go to the periodic table, and then the moles to moles in the middle you get from the balanced equation. And remember, moles opposite grams are always equal to 1. Okay, so hopefully you come to intervention day today to get some help. If not, I will be around tomorrow morning for a little bit to answer any questions you have on the study guide, and we'll see you tomorrow for the test.